If I were to get a really strong jetpack or something else that would propel you to the moon, theoretically I should be able to go to the moon, right? Well, theoretically yes, but no. Apollo 11, for example, to give context to that, is the first spaceship to ever reach the moon. On July 16, 1969, Apollo launched, setting their sights for the moon. But wait, what allowed them to even set their sights on the moon? Well, on that day was the day where the moon was actually the closest to Earth. And Apollo 11 launched at the equator, which was actually has a slightly weaker force of gravity at 9.78 meters per second compared to the usual 9.8 meters per second everywhere else in the world. Now, launching straight to the moon wasn't their goal, but they wanted to stop at Earth's lower orbit and then make their way to the moon from there. Now, this is where the first calculations come in. Apollo 11 has the mass of about 45,000 kilograms, and they need to reach Earth's orbit, which is about 185,000 meters above Earth. And it took the ship about 9 minutes to reach there, while being pulled back by Earth's gravity. To find out how fast the spaceship was moving, I used the equation acceleration equals 2d over t squared, with t being time in seconds and d being distance. Plugging everything in, I would get the equation 2 times 185,000 over 540 squared, which equals about 1.28 meters per second, which is true if gravity didn't exist. Taking into account gravity, it would be about 11.05 meters per second to reach Earth's lower orbit. Since we're using Apollo 11 as the example, we can use its mass of 45,820 kilograms. And to get the amount of force, which is 11.05 times the mass of 45,820, which equals about 506,311 newtons to reach orbit. But they aren't done yet. Their next goal is reaching translunar injection. To reach that, they would need to travel the same distance of 185,000 meters, with gravity being only 90% weaker, at 8.82 meters per second, and taking less time now at 6 minutes. To calculate this now, we would need to use the same equation as before, and get the new equation, 2 times 185,000 over 360 squared, to get 2.85 meters per second, if gravity didn't exist. With gravity, it would be 11.67 meters per second, and to convert it into newtons, it would be 534,719 newtons to reach translunar injection. And at that point, Apollo 11 is already far enough away from the Earth and would just start drifting towards the moon with no further need of the engine. And to reach that point, Apollo 11 would need about like 1,041,000 newtons to reach that point to make it to the moon. Now for you, if you had an average mass of 70 kilograms standing on the equator, stopping on Earth's orbit, and start floating towards the moon in translunar injection, you would need 816 newtons of continuous force to reach the moon.